Hi, my name is Miguel Camba. I am a senior software developer at DockYard, a digital agency that has been doing some interesting things with Svelte lately. So the title of this talk is Svelte can compile and so can you. But before getting to the topic, let's start with a story. I was building my first non-trivial Svelte app, and so far I was delighted with the experience. The developer experience was nice, the app was very fast, very responsive, the code looked concise and understandable. And also when I look at the network tab, I saw something like this. The entire app was less than 40 kilobytes of JavaScript, and this was a medium-sized app, and that was including 7 kilobytes of inline SVGs, which is extremely impressive considering a previous attempt on a different framework was well over 200 kilobytes. So you can imagine, I was very, very happy. There was only one feature left to add on the app, and that was internalization. So I thought, okay, let's research the libraries and pick the most popular one and carry on. And when I did, this is what I found. Just by adding an internalization library and maybe 30 keys, my app grew from less than 40 to more than 50. That was almost a 30% increment over the original size, and that was again with very, very little keys, very, very few keys. So I wonder, okay, this is surprising. How come an app, by just adding this library, can grow so much? What is making it so expensive? At first I thought that maybe I was doing something wrong. Maybe it was the library I chose that was particularly big. And that wasn't the case. Or I tried some other alternatives and they all move around the same numbers. Then I thought, okay, maybe I am including every language for every person, despite of only needed one. But that wasn't the case as well either. I was including only one language and I was lazy loading the rest. So then it struck me. It's not that this library is very big. It's that libraries of this kind has always been this big. And it's only now that I realize, because Svelte apps are very, very small and optimized, so it suddenly becomes evident that they are surprisingly big. And why they're so big? I started digging into how these kind of libraries work, and it's always the same. When you ask a library to translate a key, that key is looked up on a dictionary to get the ICU string for that key, and then that string is passed to a parser and tokenizer functions that generate some abstract representation that is then passed into an evaluator and feed with variable arguments, so it can generate the actual string you see on the screen. And all of this is pretty complex and expensive because this happens at runtime. And I thought that there was no need for this to happen at runtime. I thought, why are Svelte apps so fast and so small? And the reason is that Svelte analyzes and compiles your app at build time, so it can ship only the minimum amount of code that your app requires. And I thought this was a natural fit for internalization libraries. We can analyze them in backend at build time. So if Svelte can compile entire apps, we can also compile, even if it's just ICU strings, into something we can run on the browser. So I want to introduce to Svelte Intel Precompile. It's a new internalization library built for Svelte. Its API is 100% compatible with Svelte ITN, which is one of the most popular ITN libraries for Svelte. It supports all the features of the ICU message syntax, and is built on top of the Intel API present in the browser and Node natively. So you can format dates, number, currencies, and whatnot. And like Svelte, it's not actually as much as a library as it is a compiler. So let's check out how it works. This is a classical example of an internalization with some logic in it. You have count, which is a given argument. We have plural, which is a helper. We have the three possible paths that this translation can go depending on the value of count. And we have static bits that are in blue, like I have no cats, one cat, and the number of cats. So at build time with a Babel plugin, it's very easy for us to get this string, tokenize it, parse it, and then output an inline function that we can invoke directly from our app. And it's going to be extremely efficient because it's just a function call, instead of having to go through a parse step and an evaluator function after that. We just call a function. That's perfect. And even better, it's not only saving us from shipping a parser to the browser and having to parse things in runtime. Once this is passed through a minifier, it becomes extremely compact. So compact that if you look at this and remember how long the original string was, the result is actually smaller than the ICU string this thing came from. So it's a win-win situation. The results were even better than I anticipated. For a baseline app of around 12.5 kilobytes with no internalization library, adding Svelte Inter Precompile barely adds 2 kilobytes to the final bundle, and that is including the translations, whereas Svelte 89 adds more than 40 kilobytes, almost more than doubling the size of the original app. And it's also extremely fast in runtime because it can skip completely the parsing step for rendering strings. So on first paint, it's 2.6 times faster. On render, for rendering new keys, that is keys that haven't been seen before on the page and haven't been cached, it's 4 times faster. And re-rendering cache keys that has already been parsed is still 25% faster because it doesn't have to go through a more complex evaluator function. So this is a proof that the Svelte ideas can be applied to other domains of web development, yielding very similar amazing benefits of extreme performance and minimal bundle size. So that's what I have. I want you to give it a go. Let me know what you think. This is the link where you can find it. It works on Svelte right now. And thanks.